Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So we'll be looking at the nature of matter. We'll be studying chemistry today, and it is aimed at preparing us for the WAEC and JAMB examinations. So the first thing we have here is matter, and we say that matter is anything that has weight and occupy space. So matter is anything that has weight or occupies space. So it exists in three states. It exists in the solid state, the liquid state, and the gaseous state. So it can take any of this form. It can also be classified or broken down into these various components. It can be broken down into atoms, molecules, and ions. So these particular three divisions or breaking down are the basis particles of matter, the basic particles of matter. Okay, so we're going to dive into the properties of these various phases or various states. We're going to look at solid, liquid, and gas and take the properties of these different states. Okay, so on the board we have the properties of the different states of matter. So for the solid, liquid, and gas, this is a summary of the different states of this matter. So if we're looking at the property shape, what is the property of shape for either solid, liquid, or gas? So if we're looking at shape, solid is fixed in shape. Okay, now if you consider a stone, for instance, example of a solid is a stone. So this is a stone. The stone is fixed in shape. The liquid is not fixed in shape. So if I have water, for instance, the water takes the shape of the containing vessel. So this vessel, there's water inside. Understand? So if you change it to another container, that water changes the shape to fit the containing vessel. So that's why the shape of this liquid is not fixed. Now for the gaseous or for the gas, it is still the same thing, not fixed. So if I have a cylinder like this, it's a cylinder, the gas will take the shape of that cylinder. So for volume, the solid is also fixed. You agree with me that the volume of a stone or a regular shape solid is fixed. I can get the volume of that shape anywhere in the world. Is going to be that same volume. For the liquid, it's also fixed because even if I change the containing vessel, the volume is still fixed. But for gas, it's not fixed. Why? Because it can expand depending on the kind of pressure that is applied on it or the kind of environment that the gas is. So the volume can expand. So the volume of gas is not fixed. So for compressibility, what's compressibility? Compressibility is the state where a matter can be under pressure, can be reduced, can be compressed, can be pressed down. That's compressibility. So I cannot really compress a solid because the solid particles are tightly packed. So I cannot compress it. So compressibility is negligible. If I apply pressure on this solid, the volume will not change. It will not reduce. Higher pressure, compressibility is when you apply pressure, then the volume will change. So, but for solid, the compressibility is negligible. For liquid, it is light. I can actually just in a minimal way reduce the volume of a liquid if it is compressed. And for gas, compressibility is very, very high. If the volume is changing by pressure, so compressibility will be very high. Particle movement. For solid, the particles vibrate in a place. So the particles are just vibrating in one place. This particle, for instance, is not moving. It's just vibrating around its position. That is vibrating in a place. So particle movement, the particles in solid are in stationary, they are in the same place. But for the liquid, it slides over. It slides over. So one particle can move over on another particle and so on. But for gas, there is free movement. There is free movement of particles in gas. So this is the summary of all the properties of the solid, liquid, and gas state. Okay, so we dive into the kinds of two types of changes. So we have the two types of changes. We have the physical change and the chemical change. Before I even go into the description of these kinds of changes, you agree with me that the example of solid could be iron. I can have salt as a solid. Then for liquid, example of a liquid is water. Then you have ethanol. And for gas, I can have oxygen and I can have carbon dioxide. So these are the examples of this matter in their states. So, but there are two kinds of change. So the physical change. For physical change, no new substance is formed and it's reversible. Example of a physical change is the melting of ice. You agree with me that when ice melts from solid, you know, ice is like a block, this ice. If it melts from solid to liquid to water, it's water in the container, for instance. So this is a physical change because the form of this has been changed on another form. It has been changed from solid to liquid. So this is a physical change. Change happened, but this physical change can be reversed. First of all, no new substance is formed because the same water that is here, you understand? No new substance is has been formed, just that there is a physical change. There is a change in the constituent, the way the body is constituted. So this kind of change, physical, can be reversed. If I cool the temperature of this water to a very low temperature, it will come back to this. So reversibility means that, oh, I can take it back to where it came from. I can take it to a new form or take it back to where it came from. So that is the kind of physical change. Two properties. First of all, new substance is formed, and secondly, it is reversible. The second kind of change is chemical change. For chemical change, a total new substance is involved. Total new substance is formed and it's irreversible. Rusting of iron, for instance. If iron rusts, for instance, I bring, you know, from experience, if you check iron, when it's not rusted, it's shining, it's bright, it's a silver color, it's very beautiful to behold. But when it starts rusting, when oxygen starts combining with the surface of the iron and it starts to rust, you see, it becomes brown. Now, you cannot reverse that from that brownish look, you know, to how it was before, just by physical means. You can't do that. So rusting of iron is a kind of chemical change, it's irreversible. If you have some kind of combination where you have some material undergoing some degradation, understand? Like even paper that is being burnt, when it's burnt, it turns to smoke or it turns to ashes. It cannot reverse it. All right. Okay. So these are the two kinds of change that we need to know. Okay. So we go into separation techniques, and the separation techniques here are used for separating mixtures, not compounds. So mixtures are actually solutions or what is brought together by physical means, and not really that they have been intertwined. Compound is like they have undergone chemical reaction, but for mixtures, they are just brought together. The components of the what is mixed is brought together through physical means. Okay, so if we want to separate anything that is mixed together, there are different methods. I have 6 here. There's 4 first in this presentation. I'll bring up the next 2 even as we progress. So the first one is filtration. It's a method of separating mixtures. So for filtration, you are using it to separate insoluble solid from liquids. Insoluble solids are solids that cannot be dissolved. So you can see them in the mixture, you can see them inside the liquid, you can see them as particles, but to bring them out, to bring it out so that it can be separate from the liquid, you will use filtration. This is a simple method. Example is sand and water. Sand and water mixture. If you take sand and put inside water and shake together, you will see that it's mixed. For you to bring them out, you need to get a filter whereby you pour water inside the filter, and the sand is retained in the filter, then the water is drained, it's passed through. So you have two different matter. You have the solid, that's the sand inside the filter, and the liquid inside a bowl or a measuring cylinder. So the next filtration method or separation method is evaporation. So for evaporation, when you see that there are soluble solids and liquid, that means you have soluble solid. Now you see this one, the first one, insoluble solid. That means solid cannot be dissolved. But this one, now the solid can be dissolved. So let's say, for instance, solid has been dissolved inside liquid, then you can separate it. If you check, there are some solutions where you have salt from the sea, you understand? Salt from seawater. So you have salt inside water, or you pick seawater, you take seawater from the sea, seawater. You see that you will not be seeing salt particles already. But by the time you go through this process of evaporation, you see that the water escapes and the salt remains. So evaporation is used for separating soluble solid from liquids. Mind the terms because you can be asked in your exams. You'll be given this scenario, all the scenarios, you understand, and be told which way is the best method of separation. So for insoluble solid from liquid, you use filtration. From soluble solid from liquid, you can use evaporation. This is the example here. For distillation is another method of separation. For distillation, two liquids with different boiling points. So you see now we are going into, we have left solid, now we are entered liquids. You have two liquids mixed together, but the thing is that there is a physical property that you can use to separate them. They have different boiling points. Like for instance, water and alcohol. You know that water is 100 degrees and alcohol is less, understand? So by the time you heat the water, you heat the mixture of these two, water and alcohol, you heat them. The first one that boils is alcohol. It boils and can evaporate. You can collect it in another part. You understand? Collect it in with another apparatus. You understand? So distillation has to do with separating two liquids with different boiling points. Chromatography is for components of dyes or ink. So you have ink and dyes, or dyes that you see the colors, the liquid or the solution is thick and it looks uniform. But by the time you pass it through this chromatography equipment, you see that different components of that liquid is separated. So you can separate ink colors using this chromatography method. So the next two left is decantation, number 1 and number 4. It is used to separate liquid from heavier solid. So you have liquid that is mixed with heavier solid. Decantation is just a way of letting the solid go down, just leave it to stay still. After some time, the heavier matter goes down and the lighter one comes up. That's decantation. So you can now scoop it out, like oil from water, for instance. You understand? So the heavier one goes up and goes down, the lighter one comes up. Then centrifugation has to do with applying a kind of a force, circular force. You wield the solution round, and as it's going round and round, the very fine solid particles will go down, and the heavier, the liquid will remain up. So blood components are examples of how you can apply centrifugation, centrifugal force to separate. So actually, these are the kinds of methods for separation. So the exam tip I will give you, the WAEC tip I'm going to give you is that you should be able to identify the appropriate method for a given mixture. So look at all these examples, the mixtures that I gave here, and the properties of these mixtures. You understand the properties? From there you can identify which one is used or can be used. So we'll go into the atomic structure or basics. First of all, these concepts, we need to know this concept. Atom is the smallest particle of an element. So a molecule is two or more atoms chemically combined. And ion is charged particle formed by loss or gain of electron. Now, somehow the atom looks like this. It has a central nucleus that has proton and neutron, and there is an outer orbital that has electron. Let me just put one electron here to represent every kind that can happen, you can have. Understand? So this is the nucleus. These two combination is the nucleus. The center, the nucleus, and this is the orbit where the electron can go round. So inside this nucleus you have the proton and the neutron. Now the proton is a positively charged part of the nucleus. The neutron is not charged. That is why this and this will balance. So there's no charge here, zero charge. There's no charge there. And the electron is negatively charged. Let me clean this label. This one is electron minus, but the label here is electron. Okay? Okay, so you see, so the proton is positively charged, the neutron is neutral, no charge on it, and the electron is negatively charged. If you have the same number, if you have this electron and proton balancing out, then this particular atom is neutral. There's nothing, there's no charge on it. But in a situation where you have less electron than the proton, or you have more proton than the electron, you have a positively charged ion. That is why an ion can be positive. Ion can be positive is plus, or negative, minus. So what makes it positive? If the proton is more than the electron, you have positive, because the more proton over the electron, you have an extra number of proton, making it positive. So the atom itself now becomes an ion. But if the electron is more than the proton, then it's now negatively charged. Okay, so these are the concepts that we need to know. Example, sodium that has 11. Sodium, we'll look at all this later. Sodium has 11 proton. And if the electron is also 11, so this is positively charged. But situation where you have, this is P, proton, and this is electron. Where you have 11 proton and 10 electron, you agree in that and if it's 10, 11 minus 10 will now give us 1. So there's a 1 extra positive charge. That makes this sodium to be an ion, positively charged ion. Why? Because an extra positive charge over this negative charge. It's not balanced. It's not balanced. Okay, so we'll go into some WAEC-style question on this topic. We'll just see it, what we have done so far. Let's just test. Let's go and check some past questions and see where what we have just done in these few minutes can be applied. Okay, so I have some WAEC-style question on the board. Practice WAEC-style question. Number 1 says, which of the following is a chemical change? Remember, chemical change is a change that occurs that is not reversible. You understand? Okay, so we have number A, option A, melting of ice. This is physical, because if you melt ice, ice can reverse back and become water. When water is cooled, when water is cooled to a very low temperature, it becomes water. So this is reversible. Boiling of water is also reversible. If I boil water and it vaporizes to become vapor in the air, that vapor can condense, you understand, back to water. So it's reversible. So this is physical change. Rusting of iron is not a physical change. Why? Because when you rust iron, when iron is rusted, it cannot return back to its original state by physical means. Understand? So rusting of iron is a chemical change. So this is correct for our first question. Of course, dissolving salt in water can be reversed. It's not a physical change. It's not a chemical change. It's a physical change. Number 2 question says, the method used to separate a mixture of sand and salt is, remember I told you that you will be given the kinds of mixture and you'll be told, you'll be asked to pick which of these ones can be used. You see? Now, I'm going to the option. A is the answer because sand and salt, the method used to separate a mixture of sand and salt is, okay, so you can separate sand and salt through these two combination of mixture separation techniques, evaporation and filtration. How do you do that? If sand and salt are together, understand? First of all, chromatography cannot be used because we said chromatography is used for tie and dye ink and so on. Distillation is for two solids with different, two liquid with different boiling points, and sublimation is just like two solids, two liquids. No, a solid and a liquid. So when you sublime, when you heat it, the solid changes to gaseous state directly. Okay, now I'm left with this one. How? I want to explain how this is the answer. Now you have sand and salt. What you do first of all is to pour water inside this mixture, and you have sand and salt water. By the time you pour water inside this mixture, salt will dissolve in the water, and salt and water will become liquid. Okay, so you pass the sand and salt water through filtration. When you pass it through filtration, through a filter, you can collect the sand, and the filter, the sandy salt water will go through the filter and collected in a collecting vessel. That collecting vessel is heated, and the water part of that water and salt, the water part evaporates, leaving the salt. So you have separated it by that method. So A is the correct answer. And finally, which of these is not the characteristics of gases? Gases, okay, so we say that gases have no fixed shape. Yes, gases have high compressibility. I can compress gas and the volume will reduce. Compressibility comes with the fact that because gas has too many particles that are separated in large distances, I can reduce the distances by compression. Compressibility is high. So it does not have a definite volume. So this one is the answer. Particles can move freely is also a property of gas. So C is the answer. Gas does not have a definite volume. All right, so we'll come to the end of this topic today. I hope this video has been informative for you, and I'd like to thank you for viewing.